Hello, I'm here, Professor Israt Karnan with the PS students with the mechanics. Today we are starting here at chapter number 8, the mechanics from Q.K.GHORI. And my topic is about rectilinear motion. Okay, let's start here about rectilinear motion. What's rectilinear motion? Keep in mind, if the particle is moving along the straight line, the particle is moving along the straight line, then its motion is called a rectilinear motion. Okay, let's define here. If particle is moving along straight line, the particle is moving along straight line, then its motion is called, rectilinear motion. So I hope so you got to understand that if particle is moving along the straight line, yeah, this is the straight line. Particle is moving along the straight line, then this motion is called rectilinear motion. Okay. Now, two things I want to tell you. That we have A, how you can get acceleration. It's dv over dt. Keep in mind this thing. That acceleration is the rate of change of velocity. It means wherever you have A, you can write as dv over dt. And another thing I want to tell you, if you have v, velocity, it's a rate of change of displacement. So v you can write like this, dx over dt. So two things you can keep in mind, that acceleration is the rate of change of velocity. Velocity is the rate of change of displacement. And another thing even you can also write, if v is a rate of change of velocity and acceleration is the rate of change of velocity, v is the rate of change of displacement, acceleration is the rate of change of velocity, you can also write this thing. Double rate of change of displacement is called acceleration. You can write acceleration like this, you can write acceleration like this, you can write velocity like this. These two things you have to keep in mind. So another thing, revising here, I started from the rectilinear motion. That if the particle is moving along the straight line, then its motion is called rectilinear motion. Acceleration is the rate of change of velocity. And or you can also write this double rate of change of displacement. And velocity is the rate of change of displacement. Just simply. Now, the question is equations of motion. You know, from that equation, you know that you have three equations of motions. First equation of motion, second equation of motion, and third equation of motion. Now, what I'm going to do here, I'm going to prove these three equation of motions. Okay. In the paper, it can also come here like this, or find the velocity, find the velocity and distance, find the velocity and distance traveled by the particle, traveled by the particle, find the velocity and distance traveled by the particle in time t, moving with the constant, moving with constant acceleration a. Or this can also come like this in the paper, that you have to prove these three equations of motion. You know, first equation of motion is V is equal to U plus AT. You have to prove this. This is called the first equation of motion. We have a second equation of motion. This is like this. X is equal to UT plus half AT square. This is the second equation of motion that we have to prove here. Now we have a third equation of motion. Third equation of motion is this 2ax equal v square minus u square. We are going to prove these three equations of motion. Okay, let's start here. Firstly, I'm starting from the first equation of motion. First of all, I'm going to start here first equation of motion. Okay, first, I'm going to prove this thing. Okay, it's as you know only that this is a rectilinear motion. And in rectilinear motion, the particle is moving along the straight line because this is moving along the rectilinear motion. Okay, you have this particle, this is moving along this straight line. But I'm considering here that it is present at point O. When the particle was present at point O, its time was zero. At this time was zero. Velocity. Its velocity was u, means this is initial velocity. Another thing, when the particle was at point O, it covered a distance zero. This distance covered is zero. After a few time t, it reaches a point P, means when it reaches a point P, its time becomes t. You can write time is equal to t, and its velocity becomes v. And when it reaches the point P, it covers distance x. This distance means this is x. So I can see here when it reaches the point P, its distance covered is x. So again, I'm telling you here, you have a particle, it is moving along the straight line. When it because we started our motion from point O. When it was at point O, its time was zero, its velocity was u, its distance was zero. After a few time t, it reaches a point P, its velocity becomes v, and its distance covered is x. So let's write these things. Okay, let's start here. Suppose, suppose and t equals zero, particle, particle starts, particle starts from a fixed point O, from a fixed point O, and moves in a straight line and moves in straight line with constant acceleration a, with the constant acceleration a. You are watching this. A particle start from O, at t is equal to 0, at t is equal to 0, fixed point O, and it is moving along the straight line with constant acceleration a. And what happens? Suppose that suppose that particle takes a time t, particle takes time t, acquires a velocity v. Let's see here. When it takes time t, its velocity v, acquire, acquire velocity v. and travel the distance x. Let's see here. A travel a distance x. On reaching the point P, on reaching point P from O. I discussed all things here already that we are starting our motion from point O at time t is equal to 0. Velocity was u. Keep in mind that its initial velocity is u. Distance covered is 0. After time t, it reaches the point P, it covers a distance x, its velocity becomes v. I write the same things here, these things here. Okay. Now, we know that A equal to d2x over dt square. When I started my lecture, I told you that acceleration is equal to d2x over dt square. Okay, you can write also like this: d2x over dt square equal to a. If you want to get v, means I want to get dx over dt. You know, dx over dt has a derivative d2x over dt square. D2x over dt square has an integration dx over dt because integration and derivative are reciprocal to each other. So if I want to reach towards dx over dt, I have to integrate both sides. But with respect to t here, okay, write down here integrating integrate both sides. But with respect to t. So if I integrate here with respect to t, it will be d2x over dt square into dt. Here is a into dt. So what I can do here, you know, if this is d2x over dt square, its integration will be dx over dt. I hope so. It will be dx over dt. A you can take outside equal to a because a is a constant. So 1 into dt. So it's a dx over dt. A is a constant as it is. Integration of 1 with respect to t, it will be d. I can place here capital A. And you know what is capital A? Capital A is the constant of integration. And its value can be found by using initial condition. Okay, you can call it equation number 1. I will say where capital A is a constant of integration, is a constant of integration, and its value can be found by using initial conditions. You can find its value by using initial conditions. Okay, what are the initial conditions? These are the initial conditions. Means at t is equal to 0, velocity is u. These are the initial conditions. Okay, I can put here. This dx over dt, it's a velocity. And at t is equal to 0, velocity is u. It means I can write here u equal to, this is a, I can put t equal to 0 because I'm putting here initial condition plus a. So I got 0 plus a equal to u. So I got capital A value equal to u. So now what I can do, I can put this a in equation number 1. Okay, put the value of a in equation number 1. So what will happen when I will put a here equal to u? This is dx over dt equal to at plus u. Dx over dt. This is v, means this is velocity. Okay, I can write V equal to this is U plus 8. So I got a proof of first equation of motion. Keep in mind this is called first equation of motion. Now I have to move towards second equation of motion. Then I will move towards the third equation of motion. Okay, okay, okay. Let's come here. That now we are moving towards second equation of motion. Okay, okay, okay. Let's see here. Now, even you can write second equation of motion. I'm going to prove this thing. This is V, you know, V is equal to U plus AD. This is first equation of motion. For proving the second equation of motion, I can use the first equation of motion. No issue. No issue. Okay. Okay, V equal to dx over dt. Yes, I can write equal to U plus AD. If you want the second equation of motion, in second equation of motion, I need the value of x. If I have a dx over dt, if I integrate it, I will be getting x. It means from here, if you want to get x, you have to integrate it both sides. You will be getting x. Okay. What I will do here, integrating, integrating both sides. Keep in mind that you are integrating here with respect to b. Okay, this thing, the x over dt into b. Here, u dt plus at dt. Okay, you know these things? That x has a derivative dx over dt. It means dx over dt has an integration x because integration is a reverse process of derivative. It means dx over dt, its integration will be x. You can be taken outside. You have a 1 dt plus from here a can be taken outside. You have a t dt. Okay, x equal to u. Integration of 1 with respect to t, it will be t. A will be as it is. The integration of t with respect to t, it will be t square by 2. I can place here b. Then I can call it equation number 2. Why? Because b is a constant of integration and I can find the value of b here by using initial conditions. Okay, what I can see here, where capital B is a constant of integration, is a constant of integration, and, and its value can be found by using which thing? By using initial conditions. You know already that what are the initial conditions? Means at t is equal to 0. Let's see here. At t is equal to 0, distance is 0. Distance. Distance means x. It's 0. So if I put here x equals 0, t equals 0, I will be getting b equal to 0. So if I put these things, x equals 0, here let's see, u into 0, it will be u into 0. Plus, if you put here t equals 0, what will happen? E into 0 square by 2. And we have a capital B here. It's a 0, it's a 0, it's a 0 plus B. You will be getting capital B equals 0. So I got a capital B. So now what I can do? I can put this B in equation 2. I got integration constant. Now put this B in equation 2. Okay, let's see here. If I put B equals 0 in equation, what will happen? Let's see here. X equal to ut plus half at square plus b0. So this is x. X equal to ud plus half at square. So I got a second equation of motion. This was the first equation of motion. This is second equation of motion. Now what I will do, I will move towards the third equation of motion. And even if I want to prove say third equation of motion, I can use first equation of motion. I can use second equation of motion for proving the third equation of motion. Okay, let's start here. First of all, we see here that what is the third equation of motion? Okay. Now I'm moving towards, let's see here, third equation of motion. And what is third equation of motion? Third equation of motion is this: 2ax equal v square minus u square. Okay, I'm moving towards its proof. Okay, for proving this, I can use first equation of motion as well as the second equation of motion. You know already what is the first equation of motion? First equation of motion was this, like this: v equal u plus et. What is second equation of motion? It was x equal ut plus half at square. Okay, if you notice these things, you have a t here, you have a t here. But in the third equation of motion, there is no t. So what I have to do? I have to do something that I want an equation free from t. I want to eliminate a t. What I have to do? I will get t from here. I will get the value of t here, and I put here. I will be getting equation free from t. Maybe I'll be getting a third equation of motion. Okay, let's see. From here you can get a t. V minus u equal to ab. You want to get a t here. It means it will be v minus u divided by a. I can call it equation number 1. I can call it equation 2. And what I have to do? I have to put 1 in 2. And if I, oh, okay, put 1 in 2, x equal to u, and what is the value of t here? And I think so, t is this one, v minus u divided by a plus half a, and I have to put here t square. It means it will be v minus u over a and its square. Okay, what you will do here, x equal to u, and here is v minus u divided by a plus 1 by 2 a, and here is v minus u its square, here is a square. Its a and square will be cancelled. Then you have x equal to u v minus u over a plus, and here is v minus u whole square divided by 2. What you can do, you can take its LCM. Okay, let's take its LCM. And I think its LCM will be 2. A will be divided, you will be getting 2. 2 will multiply here. It will be 2u into v minus u. Plus, you will divide 2a here, you will be getting 1. 1 will multiply with this one. It will be v minus u and its whole square. You can simplify it. This 2a, this will come here and it will multiply with x. You will be getting 2ax equal to 2u into v minus u plus v minus u in its whole square. You can simplify it. 2ax equal to 2u, you can multiply. It will be 2uv minus 2u with u. It will be 2u square plus v minus u whole square. It will be v square plus u square minus 2uv. You know the formula: a minus b whole square, a square plus b square minus 2ab. Okay, let's see here. It's a plus 2uv, it's a minus 2uv. This can be cancelled. So you are getting here, this is 2ax. equal to, okay, let's see here. This is v square. You have this is minus 2u square. This is plus u square. Minus 2u square plus u square, it will be minus u square. So what is this? This is third equation of motion. So we got a proof of the third equation of motion. My dear students. So I can say here, this is third equation of motion. So, my dear students, today we got equation of motions, proofs of all equation of motion, and even we discussed about the rectilinear motion. So, I hope so you got to understand all these things. And if you like my lecture, you can comment me. Thank you. Bye bye.